Good evening. I am Pranavi from CSCE section. Today I am going to present a PPT on the topic sources of electrical resistance. So let's start. Sources of electrical resistance. It is a property of a electrical conductor to oppose the flow of electrons is known as electrical resistance. So it is usually represented by R, and the SI unit of the resistance is ohm, and it was named after the German physician named George Simon Ohm. He gave us the Ohm's law and the relation between the current, voltage and the resistance. 1 ohm can be defined as the resistance of a conductor in which the current flow of 1 ampere flows when a voltage of 1 volt is applied. Next, in metallic crystal, the electrons move periodically, varying the electric potentials of positive ions of the lattice. The reason for the electrical resistance is just uh, electron scattering, and the reason for the electron scattering is the non-periodicity of the lattice potential, and the cause for the non-periodicity of the lattice potential are three: the thermal lattice vibrations, presence of impurities, presence of defects. So let's learn one by one. When electrons are moving freely associated with the de Broglie's wave, then the electron moves similarly like an electromagnetic wave without any disturbance. Uh, without any disturbance. So according to the classical free electron theory, the resistance is due to the collision of free electrons. When two free electrons collide with the positive ions, then the electric resistance is caused. So now let us learn in detail the causes of the non-periodic potentials of the lattice. First is the thermal lattice vibrations. According to quantum theory, free electron theory, when the electrons move randomly in a metal, which the metal is scattered by a positive ions, uh, then it leads to the electrical resistance in the metal. In general, when we do not apply any field, the positive ions have their vibration constant, and it is due to the thermal energy. When when an electron, that is a free electron, uh, gets encountered with the vibrating positive ions, the it gets scattered. This scattered is known as phonon scattering, and it is one of the main source of electrical resistance. Next, when the temperature is high, the resistivity is proportional to the temperature. The temperature increases and the resistivity also increases. When the temperature increases, the vibrations of the positive ions will be increasing. That is, non-periodicity will be increasing, so the resistivity increases. When the temperature is zero, some materials show zero resistivity. As for some material, the resistance shows equal or not equal to zero. So here there is a formula: rho is equals to rho I plus rho of T. Rho is the resistivity. Rho I is the resistivity due to impurities and the defects, and P of T is the resistivity due to thermal vibration. So next, presence of impurities. When the impurities are present in a metal, the periodic arrangement of the atoms, the normal arrangement of the atoms, gets disturbed, and it leads to the electrical resistance. When the concentration of impurity increases, the resistance also increases. Here we can see the graph: resistivity versus temperature. Here pure also increases, impure also increases, and the more impurity also increases, that is, the resistance also increases when the impurity increases. Next, When the impurities are present, the periodicity of the electric potential also changes, and the when impurity increases, the atomic sites which exist, they cause a large electron scattering, and that is nothing but the resistivity. Next is the presence of defects. When there are any defects present in metals like point defects, line defects, surface defects, that also leads to the electrical resistance. When there is a presence of imperfections like vacancies or the boundaries, it changes the periodic potential. When there are large number of defects, then there is a large non-periodic potential. So when there is a large, then there will be a large electron scattering, and the resistivity also be high. Thank you.